Alright, in this tutorial we are going to be working basically on how to resolve multiple vectors, right? So here is a simple diagram for us to use. We have f1 vector f2, we have f3 and f4. Now one thing you must note is the angle formed between any of the vectors must be to the horizontal. So with that, we will be able to resolve everything completely. So let's start. I'll first of all start by sketching this diagram again. So here we have our vertical line and our horizontal line. So let me quickly note this guy here to be my fx. Let me call it positive fx, and then this is negative fx. So here we have positive fy, and then here we have negative fy. Very important for us. Very important for us. So here we are going to be sketching some vectors here. So we have this f1 having an angle to the horizontal theta 1. Here we have vector 2 called f2. It has an angle theta 2. Here we have f3. It has an angle to the horizontal called theta 3. Um, Here we have vector 4 called f4, and it has an angle to the horizontal. We call it theta 4. Alright, this is exactly what we have here from the other diagram. Now it is good for you to know that on this diagram we have the positive axis and the negative axis. We have to resolve all these both vertical components and then the horizontal component. Note that fy represents vertical components, then fx represents horizontal components. So we'll start by resolving all these vectors first of all to the vertical component. So we move. So from the previous diagram, we have I want to pick from F1 first of all. So I want to draw a line from here, a straight line to this point. So this line still represents our Fy1. I call it Fy1. Now here I have this place to be my Fy2. Here I have uh, here I have Fy4, and here I have Fy3. Okay, so let's pick the first one and work with it. So resolving pseudo vertical fy components. So first of all, we have this here. So I call this guy my fy1. So this one becomes our f1 resultant. Here is the angle that is formed. So here becomes what our fx. Remember that is a positive fx. Alright, so here using we have a shortcut here that we can be using SOH, CAH, and TO. This sine theta is opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Then we have T to be opposite over adjacent. So from here, we have sine theta to be equal to Fy1 divided by what? F1. I call this guy F1. I'll call it F1. So here we have this implies that Fy1 is equal to F1 sine theta 1. Remember, this is theta 1, so we have to include it here. This is theta 1. So this is the first one that we have. Now, if we move, I'll quickly underline it. This is the first one that we have. Now, we have another diagram. Here, we move to the second quadrant where we have our F2. Now, our F2 is giving us this from here this way. So I call this one to be my Fy2, and here becomes my F2. Here becomes my negative Fx. So remember that this is the origin, and then we have theta 2 here. So how do we work around this guy here? So we have, remember that sine theta is opposite over adjacent. So we have here sine theta to be equal to opposite is Fy2 divided by what? F2, which implies that Fy2 is equal to F2 sine theta 2. This becomes our second one. So we have it this way. Now we move to the third quadrant where we have this where we have something of this nature down here. Remember that on the third quadrant we are on the negative of x and negative of y. So here we have minus Fy downward because this is the movement. So here becomes theta 3. Here becomes Fx. Remember it's minus, so we have F3 as a resultant. So here we have sine theta 3 to be equal to minus Fy over F3. So here minus Fy could we place this to be Fy3 minus Fy3 is equal to minus Fy3 is equal to opposite over adjacent. Alright, so here we have I think there's something here we need to adjust. So here we have this is minus fy3. So we have minus fy3 to be equal to f3 sine theta 3. Automatically, this by implication is equal to fy3, which is equal to minus f3, which is, of course, you know f3 is a resultant on the third quadrant. So here we have sine theta 3. So this is all we have on the vertical resolution for the third quadrant, the vertical axis. Alright, finally if you check this diagram one more time, we discover that we have another quadrant here called the fourth quadrant. So all we need to do is just to sketch it. On the fourth quadrant, we have this, and then we have this. Alright, let's draw it to the other side so that we'll be able to write on the other side. So here we have this. Remember, is acting downward, and then here we have this. So this is our theta 4. We are still on the negative side of the y-axis, so we have minus fy3. This is f3, which is the resultant. No, we are dealing with 4. So here we have here we are having f4 resultant fy4. So here what do we do? We still say sine theta 4 is equal to opposite is minus fy4 divided by what? f4. By implication, uh, we are having minus fy4 to be equal to f4 sine theta 4. So here we must take away this minus from here so that we can have fy4 components to be equal to minus f4 sine theta 4. So this is what we have on the fourth quadrant. On the fourth quadrant. On the fourth quadrant. All right. Now, in summary, we have fy1 to be equal to f1 sine theta 1. We have fy2 to be equal to f2 sine theta 2. We have fy3 to be equal to minus f3 sine theta 3. And then we have fy4 to be equal to minus f4 sine theta 4. So this is all we have on the y component. So we need to move straight ahead to the horizontal resolution. So on the horizontal resolution, now if you recall the first diagram that we have here, we have fx minus, we have fx plus. So we have to resolve the entire of this thing again to the x component. So for x component, we have let's sketch this diagram from the first quadrant again. We have something of this nature. Here we have it looks like this. here we have from the first quadrant we have something of this nature. Alright, this is theta 1. Remember, this is going to be what? Our fx1. And this is going to be what? Our fy component. So here we have our f1. So to horizontal components, we have adjacent over hypotenuse. So we have cos theta 1 is equal to our adjacent is what? fx1. Our hypotenuse is what? f1. So by implication, we have fx1 to be equal to what? f1 cos theta 1. So that is the first thing we are noting from here. Now we can also move on from here. We can also sketch for the second quadrant this way. We have it drawn to this direction. So this is our theta 2. Remember, on the second quadrant, x is supposed to be negative. So we have fx2 minus. So here we have our f2. Remember, this is still supposed to become what? Our fy. So at this point, we have cos theta 2 is equal to what? Adjacent, which is minus fx2 divided by what? f2. So here we have fx2 minus is equal to what? f2 cos theta 2. But we need to let go of this minus from the left hand side of the equality sign. So we have fx2 to be equal to minus f2 cos what? Theta 2. So this is what we have on the second quadrant for resolution to the x direction or x component. So we underline it this way. Or create a box round about it. Now we can move to the third quadrant. On the third quadrant, we have something of this nature. This way, we have something like this. This is theta 3, and remember we are still on the negative side, so we have minus fx3, and this is still fy. Remember, it's still a negative value downward, so this is f3. So now on this, we can have cos theta 3 to be equal to adjacent over hypotenuse. Here the adjacent is what? Minus fx3 all over what? f3, which implies that fx3 is equal to minus f3 cos theta 3. So this is what we have here. Alright, so from here we have something x here. I think this is the last part we are going to do. So we have here for the fourth quadrant, we are moving downward here. Okay, we have theta 4. Now we are on the positive sides of the positive of the x-axis. X positive axis. So we have fx4 positive f4. So the resultant for this becomes the f4. At this point, we still have this guy to be fy. So if we have this guy to be fy, so we can have cos theta 4 to be equal to what? Adjacent over hypotenuse, which is what? fx4 divided by what? f4, which implies that fx4 is equal to what? f4 cos theta 4. So this is the last part of it. Now we can just do a summary. We can write out the summary for this. Alright, so here we have therefore for x components we have fx1 to be equal to what? F1 cos theta. We have fx2 to be equal to minus f2 cos theta. Then we have fx3 to be equal to minus f3 cos theta. And then we have fx4 to be equal to plus f4 cos theta. So this is what we have now. If we bring the one for the y, we are going to be having this is y component. This is y component. We still have fy1 to be equal to what? F1 sine theta. Then we have fx2 to be equal to f2 sine theta. Fx3 to be equal to what? F3 minus F3 sine theta, and then Fx4 is equal to minus F4 sine theta. So this is what we have. Now we can find the summation the of the x component. So we have x total, total summation to the x component. We are going to be having something like so let's add up all these x components, summation of x components, summation, sum of the x component vector. We have fx is equal to fx1 plus fx2 plus fx3 plus fx4. So our fx is equal to, what is our fx1? Fx1 is f1 cos theta 1. Fx2 is minus f2 cos theta 2. Fx3 is also minus f3 cos theta 3, and then plus f4 cos theta 4. Now sum of the y component vector, we have fy is equal to what? Fy1 plus fy2 plus fy3 plus fy4. So here I have fy to be equal to, my fy1 component is f1 sine theta 1 plus f2 sine theta 2. When we go down to the third quadrant, we are going to be having minus f3 sine theta 3, and the last one is still going to be what? f4 sine theta 4. So on the 2, so here this is the summation that we have. For the x, we have this. Yes. And for the y component, we have this guy here. So after everything, all you need to do now is, let's go back to this. So at the end of the day, we will succeed, or we have succeeded in resolving this. The whole of this component have been resolved to what? Fy and what? And fx successfully. Now we will now look for what? Our resultant, either r or we have fr. So resultant first here will still be the same as fr to be equal to fy squared plus fx squared. The direction of the resultant can also be, we can sum everything together. Direction will still be the same thing as theta equal to what? Tan inverse of what Fy and Fx. So it's the same thing that we are working around. So thank you so much for your time. I'm glad you followed all through from what we have done. All right. All right. You can drop your question on the comment section. Thank you.